Tyler here with projectsinmetal.com, and today we have a special treat. I'm over here in Port Angeles with Jim Schroeder, and he's going to give us a tour of his shop and show us some of the modifications he's done with his G0602, the 10x22 lathe that Grizzly produces. So Jim, why don't you go ahead and give us a tour of your lathe?
One of my recent changes was to add a digital display for the tailstock, which is made out of a 4-inch caliper. I took a cutting wheel and removed the jaws for the caliper so that all I was left with was the reading head and the scale, and attached that with a simple aluminum clamp. Another change that we've made is we've added DROs both for the Y and for the X-axis, a 24-inch on the X-axis and a smaller 8-inch on the Y-axis, and it's connected to a Shumatech 550 DRO display assembly. I've also added a shelf so that I have some place to put all the odds and ends that you inevitably collect, and another shelf above that to hold all the various tool holders that I've accumulated over the years. Of course, I got a quick connect tool post, but just about everybody has those nowadays. This is a phase 2, and I added a shield over the top of the chuck that also is an electrical disconnect. So if you're running the lathe and you lift this, it turns off the power. To restart the power, just press the green button. This is the method that I use to stop the lathe all the time, rather than using the other switches. Let's go down. Well, we made another small change here, and that was simply a extension with a little lever on it for the carriage lock, rather than having to use a hex wrench.
And then you have a cam lock on your tailstock too.
Yes, cam lock on the tailstock makes it easy to lock it in position, no wrenches.
Did you have to put a spring underneath yours? I noticed on mine.
No, just gravity.
Really? Because on mine it catches. So I'm going to have to put some sort of spring on it when I do a cam lock on my lathe.
Yeah, no, this seems to work just like that. The first change that I made down at this end was to put a DC motor on there so that I would have variable speed. So if you want to thread, you can do it at a very slow speed and have much better control. Or you can run it up to about 2,000 RPM. Another change that I made was I added an index wheel, which is used to make calibrated dials and knobs of one type or another. There are 2 rows of holes here. The outer one is 1 degree increments, and the other one is base 10. So if you want to do something in decimal as opposed to 360 degrees, you can do that. I also added a carrier for an idler gear that allows you to reverse the direction of the feed screw, the lead screw, so that you can do left-handed threading.
Do you want to try and show them how that works?
Sure. So you put the idler gear in position against the driven gear. So now everything runs the other way.
So now because I know a lot of people are going to be wondering whether they should go with a VFD motor or a DC motor if they're going to be, changing their motor out at all. Since you've done the DC conversion, if you had it to do over again, would you do that again, or would you go ahead and get a variable motor?
No, I get the variable frequency drive. I have that on the mill, and my first effort was the DC motor, and this is a 2 horsepower motor. But after a couple of years of experience with this and comparing it against the variable frequency drive, I think the variable frequency drive is the way to go because you get better torque at the low end, which you don't get with permanent magnet motors. This is out of a treadmill, which is a pretty common motor to use. The KB controllers that I use, which are a standard industrial type DC controller, give some feedback but not quite enough to compensate for torque loss at the low end.
Did you have to make a different plate? It looks like the plate that your door is attached to is different.
No, it's the same. Same one.
It looks different than what I've got on mine, I think. I think they've enclosed the motor a little bit more on the version that I have. I think, how old's your lathe? 4 years?
3 years probably.
And
2.5.
Just in case people are wondering, you did repaint your backsplash.
Right, I repainted that.
Because I'm the same way. I thought that it was kind of odd for it to be green. So, and the chip tray is green too, normally, right?
Yep, I repainted that.
How did you get the stock color? Did you go to an auto body shop and have them?
I went to Home Depot and bought the closest thing I could find, and it turned out to be an excellent match.
Wow. Yeah, and now you could probably have them mix it for you, although I don't know if they mix enamel colors or if they just mix like house paint, but excellent. Well, it definitely looks a lot better without the green chip tray and backsplash, but
Another change I made was this little spider handle that goes on the end for manual threading.
and that'll work with the door closed as well?
Yeah. Yep.
Yeah, that makes it nice. You can thread right up to the shoulder without being nervous.
Can't close the door with my handle like this.
Oh. Now, one of the nice things about your reverse design is that everything's enclosed inside. Some of the other designs that I've seen, and even the designs that we've got on projectsinmetal.com, have a kind of an external lever to switch between forward and reverse. But I kind of like the way your design is nice and elegant and all enclosed inside.
Well, the other design probably has an ease of use feature, but I rarely use the reverse.
Right.
I mean, you would only use that when you're doing left-handed threads, so
Right.
it's not something that's very common.
Right. So I thought we'd take a quick tour of your shop, starting with the machines you started with.
So this is Rev Zero. Like most people, I started with a mini mill and a mini lathe that I bought from Harbor Freight. Made a number of changes to it, added stepper motors to the X-axis and the Z-axis to improve the usability of the device. But nowadays it doesn't get quite as much use as it used to. I didn't make really many changes to the lathe or to the mill other than the stepper motors that I mentioned. I've since graduated to a larger piece of equipment that I use on a regular basis, and this is a Grizzly mill. I can't remember the number. I think it's a 3358. And it's got variable frequency drive, which I added, and since it's a mill drill, when you change the height of the head, you have the alignment problem. So I use a laser that's projected against a mirror at the other end of the shop that comes back to this wall, which gives me a total travel of about 38 feet, which makes the realignment actually pretty easy.
Well, that's pretty clever.
This also has a Shumatech 550 DRO connected to capacitive type Chinese scales, which I'm in the process of replacing with glass scales. I mentioned I added the variable frequency drive, which is really nice. You can tap, you can run this at a very slow speed. Something like that, if you want to tap, or you can run it up. And you also can reverse it. So if you power tap, you get to the bottom of the hole, hit reverse, and back it out. I added a spider level lever to replace the original lug wrench type that came with it, and the bars to tighten the column. Other than that, it's more or less the same as the way I got it. You want to talk about the cutter grinder?
Yeah, this one that's coming up in which magazine?
Home Shop Machinist.
Okay.
This is based on the original Derek Brooks design that was published in Model Engineering. I believe it was 1991 or 1992, something like that. I have since modified this to put linear bearings in here to make the operation a little smoother. I have likewise changed the tool head to give me a greater range of motion. And I've modified the grinding head so that you can move it from one side to the other, which gives you a much larger work envelope.
Yeah, you were saying the original design had a bigger table and
Had
didn't need
a
to.
longer, heavier table, and it was a little cumbersome to operate. This will also sharpen flutes. This attachment replaces this table, and it uses standard R8 type collets, and you can put your mill in there and sharpen the flutes. It also has a head that will take ER20 collets so that you can sharpen just about any size drill if that's a requirement.
And then, of course, from your smaller lathe, you graduated to the
Grizzly G0602.
Now, how have you liked this lathe? I also own this lathe, and I like it, but I don't have...
Well, I can only compare it against my little Harbor Freight. So it's probably not a
fair comparison.
Not a good comparison, but I looked at many different lathes before I bought this one, and I thought for the money that this was by far the best buy.
Do you think that you're going to outgrow it anytime soon?
No.
Because that's one of the concerns that I see a lot on the forum and on other websites where people are like, well, gosh, I don't know how big of a lathe I need. And
yeah, but then the problem is you have to go to floor-mounted equipment that requires riggers to move it around for you.
Yeah.
I don't want to get into that situation. If for some reason I should want to move, I want to be able to take my equipment with me, and I don't want to have to go through a lot of special effort to do it.
Right. Now, one other thing I wanted to show them was the way you've got everything set up. Each tool is kind of on its own little custom-built cabinet. Now, on your lathe and your mill, you said that you had to go ahead and put them up on blocks to keep everything.
To keep them accurate, yes.
But
the alignment on the lathe would change. You'd start to pick up a taper. Mm-hmm. And on the mill, you would lose tram.
that surprises me on the mill. You wouldn't think that there'd be enough of a flex in that.
Believe me, you do.
No, on a lathe, it's a little different because it's so long. But I just thought this was pretty cool because I haven't seen a built-in setup like this before, where somebody's taken the time to put cabinets together around a toolbox like that. So what else do you have right here?
ER40 collet which goes on the lathe. So I find this to be much more usable than the C5 collets.
Well, and I don't think it sticks out as far either, which is good.
No, it doesn't. No.
Because I
Very
think
compact.
Little Machine Shop sells an adapter plate that you can get, but it would stick out. Here, hold that back up again. The nose of it sticks out quite a bit further. That doesn't stick out any further than the original 3 and 4 jaw chuck.
Right.
Actually, a little less.
Yeah, and this threads right onto the spindle thread.
Wasn't it like 1 inch and
Inch and
8 threads per inch or
inch
something?
and 3/4 by 8, I believe it is.
Yeah, kind of an
It's an
odd.
odd size, yeah.
So did you obviously had to single point thread the inside of that?
Oh yeah, sure.
I didn't imagine you bought a tap specifically for that one.
No. That was single pointed.
Yeah. Excellent. I think we're going to start one other little short video here and show you the difference between the surface finish you get using a insert and what'd you call the tool?
This is a tangential shear tool. It shears the material off in a different fashion. Is your camera running right now?
It is, yeah.
Okay. If you can see the edge on this, it runs at an angle like that. And as it moves, it'll only take off a few thousandths at a time, but as it moves across the material, the chips that you get are long strands, similar to a piece of hair, except finer. And it leaves a incredible finish. And this idea came from the gadget maker, gadget builder.
Yeah, gadgetbuilder.com.
Yeah, John Moran, quite a creative guy.
Is he out of Connecticut, you said?
In Connecticut, yes.
Yeah. All right, well, let's set up the camera for a different angle and we'll show you this. All right, so what's the tool we have in there right now?
This is a WNMG insert. It's a negative rake tool. There's 6 usable edges for each insert. It's triangular shape, and you can flip it over and use the other side. So this is 12L14 leaded steel. So the surface finish that you get here doesn't look too bad, especially if you compared it against 1018. 1018 would have a much grainier appearance. So now let's go back and replace this tool with the shear tool. This is a combination of lard and Molly D. I don't know if that'll show up on camera.
No, it's actually almost too fine to see.
The gossamer strip.
I'll zoom in when we've got a pile of it here in a second. So stop it about halfway and then we'll clean it up and see how it compares. So it might be a little hard to see on the video, but you can feel a difference when we were
With your fingernail you can feel the difference, yes.
when we were doing this earlier. We were a little hard to see the difference, but maybe with my still camera, I'll be able to take a photo that'll show the difference a little better. But that's pretty cool.
There are the chips.
Zoom back out. Yeah, God. That's great. Cool. Well, thank you for. So that was called a what again?
It's a tangential shear tool.
Shear tool. Okay. Yeah, I have a tangential tool holder. I've got the diamond tool holder by Eccentric Engineering, but you made your own here. If you had it to do over, anything you'd change on your design?
Oh, probably, yeah. But this is the go-to tool. This is what I use for 80% of the work.
Yeah, I've noticed I get a much better finish using that than your regular high-speed steel tool. But I'm gonna have to go home and grind myself a shear tangential shear tool, because that looks pretty cool. All right, well, thank you for showing us that. Thanks for watching. If you'd like to see free project plans, tips, and tricks for the amateur machinist, please visit projectsinmetal.com. And if you're interested in additional videos, go ahead and visit the YouTube channel, youtube.com/projectsinmetal. And please do not forget to subscribe. Thanks.